What's going on YouTube? This is Ipsec and we're doing Fortune from HackTheBox. And this video may be a bit short or jumpy because I believe I caught a cold while at a conference in Europe last week, so talking isn't on the highest of my priority list right now. That being said, the box itself was rated as insane, but I'd probably put it as medium to hard if you've done all the previous HackTheBox machines, because there isn't really anything new other than it just being on a unfamiliar OS, which is BSD. It starts off with a super easy web injection, then goes into creating a client certificate that we've done in like La Casa de Papel. I've done in the securing vendor web app video. I think Sizzle did it. So client SSL certificates, we've done a few times. After that, there's some NFS tomfoolery, which we did in the jail video a long time ago. And then after that, it's just decrypting a password that's in a Postgres database. So there's nothing extremely hard about this box. It's just putting together an attack chain and working on an OS you're not familiar with. So that being said, let's just jump in. As always, we're going to start off with the nmap, so -sc for default scripts, sv, enumerate versions, oa, output all formats, put in the nmap directory and call it fortune, and then the IP address, which is 10.10.10.127. This can take some time to run, so I've already ran it. Looking at the results, we have just 3 ports open. The first one is SSH on port 22, and that banner says it's OpenSSH 7.9. The next thing we have is HTTP on port 80, and it says OpenBSD HTTPD, which means this is an OpenBSD box. Doesn't mean all that much to me when I'm looking at OpenBSD web servers. I just know that it's going to be slightly annoying because the command line arguments or file locations may be in different things. So whenever I do my initial exploits, I do something extremely basic, because if I try just like a command that normally works on Linux, may not work on BSD, and I'll get a false negative, which means I exploited a thing, but it failed, so I thought my exploit failed. So just keep that in mind as we move forward. The next thing we have is nmap thinking this is HTTPS because it is 443 and it's open, but none of the scripts successfully completed. We see the output of SSL date says TLS randomness does not represent time. Don't know what that means, so let's start off by looking at port 443. So I'm going to go to HTTPS 10.10.10.127, and we see right off the bat, it's asking us to present a certificate. If you don't get the screen, chances are you just haven't done other boxes or watched other videos, because this certificate we had created in the Money Heist video or La Casa de Papel, and then this other certificate is one we had created in, I think, the securing vendor web apps. So we can uncheck remember this decision and go forward, and we just get SSL error unknown CA alert. If we try to grab the certificate, FireFox does not appear to be letting us. So I'm going to use OpenSSL to grab the certificate and look at it. So we'll do OpenSSL s_client-connect 10.10.10.127 port 443. And if we look at the results, we can see the certificate, but we also get 2 potential users. We have Charlie and Bob, and they're at fortune.htb, which is most likely the host name of this box. And then we also see there is a intermediate CA, which is just a certificate authority that's signed by the root CA. And this is more for like security by compartmentalization. So you have multiple intermediate CAs, and you may say, hey, this branch of this company gets this CA, this branch gets this CA. And that way, if a branch of the company gets compromised, not all your certificates are compromised. You can just revoke that one compromised branch's intermediate CA things that it signed, and you'll be fine once you put a new one out. So just more of just not putting all your eggs in the same basket with intermediate CA, but it behaves just like a root CA cert if you do get this. Maybe that makes sense, maybe it doesn't, but let's move on. Since this is requiring a client cert, there's nothing we can really do on that port. So the other port that was listing is 80, so let's check out what is on port 80. So I'm just going to get rid of this S, go to this website, and we say, please choose from a database of fortunes. So I'm going to click fortunes, next, and we just get your fortune is. If I refresh the page, it's just choosing random things. If we go try again, click submit, we get something else. So let's just see exactly what's happening in burp. So I'm going to switch my proxy to burp. Make sure we are intercepting. Intercept is on. Click try again. Let's pick Star Trek and submit. I clicked burp, but it went on default. That is odd. And it doesn't appear to be intercepting. No, it is. Okay. So we have it intercepted. Click go. And here it is, the output. So we can play with it a little bit by just seeing what happens if we put a bad database. So like, please subscribe, and see what the error message looks like. It just doesn't give us a fortune. If we put like a star, doesn't do anything. If we do Star Trek or 1 = 1, try like Star Trek and then a comment, and we just see it erroring out. So generally what I do is I switch to wfuzz, and let's do a quick special character fuzz. So we'll do wfuzz-w for word list, user share sec list, then fuzzing and special characters. And then we would do -d to do data. This would be db equals Star Trek, and then fuzz and capital, and the URL, which is http 10.10.10.127. So what that's going to do, if you look at the special character fuzzing list, it's just a list of special characters. So we're just put all the characters in and see what happens. So it looks like, oh, we didn't do /select. There we go. So we have mostly things that are 293. So we can just put like an underscore and see what happens. I'm guessing that means there was no fortune. So if there's no fortune, it's going to be a length of 293 characters. So I'm going to do --HH to hide characters, and I'll specify 293 and run this fuzz again. And we get only 4 outliers or abnormalities or whatever. The ampersand, and that is 364, which is odd, but if you think about it, we get random fortunes every time. So this is 581 bytes. Now it's 530 bytes because the fortune changed. And this may just be doing some type of URL encoding. So let's URL encode it. And we still get a fortune. So, and it doesn't really affect it. Let's look at plus. So if we do a plus, nothing happens. If we URL encode the plus, we get no fortune. So plus definitely messes up. And I'm thinking maybe the plus doesn't do anything because the server may translate this into a space, and then Star Trek space, it may just chop off that space and it may work. So that is odd. We got a \, so let's try that. Click go. Nothing happens, and \ is known for escaping characters. So if it escapes, it shouldn't really do anything if we put a \ before R and escape R, because escaping R does nothing. If we escape the escape and then put R, this probably will fail. Yep. But if we put 3, let's see what happens. It still fails. So \ is being used as an escape most likely. And then we have semicolon. So if we put a semicolon at the end of Star Trek, nothing happens. So based upon these, I'm going to guess there's potentially command injection, because all these are known for like interacting with a command line. Like the ampersand, \, and semicolon. This plus, we think it's just a false positive because it wasn't URL encoded and it got treated as a space. So let's try semicolon ID for like a command. And we get a command ran. So we can do like which nc to see if netcat is on the box. We see it is, user bin nc. So we should be able to netcat back to us. So 10.10.14.3, port 443, nc lvmp 443, click go. and we don't get any connection back. So there may be a firewall. We can also just double check our ton 0. It is 10.10.14.3. We could try ICMP, so TCP dump -I ton 0 ICMP. And we can do, I really hope it's -C, -C1. Let's see. Ping -C1 127.0.0.1. That went once. Hopefully BSD doesn't change this. 10.10.14.3. Click go. And we can ping, but we just can't do netcat. So let's just create a Python program to make exploiting this a bit easier, because it's just a pain reading the output in this. We could probably just do db equals ;ID and then click go. And we got a random fortune with no db. That's funny. And you could also go into burp options, I think, if you wanted to use burp and create a hotkey. Is it miscellaneous? Yeah, hotkeys. So if we edit hotkeys, there should be a repeater go. And there it is, issue repeater request. So you can just click on the hotkey and then do like Control Enter, click OK, and then when you go to the repeater tab, you can just hit Control Enter to run commands. So we could change it from ID to ls-la, Control Enter, and C commands. But this is still a bit of a pain to read results. So let's go over to Python and create a quick program. Let's call this cmd inject.py, and then we can do our import statements. The first one we want, of course, is request to make HTTP request. Then we want regular expressions, because we want to grab the output of a command, because we don't want to grab all this stuff. And thinking about this, we could probably just put a bad database like please sub and then semicolon, and that doesn't give us fortunes because the command fails. So putting something here is better than nothing, because if you have nothing, you get a fortune. If you have something, you don't get a fortune. So keep that in mind. And the last thing we want is, or like command or CLI program or class that we always use. This should be familiar to you. We do it, seems like every other video I create a script using this. So you should know this by now. The prompt is just going to be what the terminal is. You'll see in a second. Then we got to create the default function. So self args. And for now, we'll just print it out. And then let's create the loop. So terminal and term is cmd loop. So let's test, make sure this works. Okay. And this should just print hello world. There we go. So our CLI is working. Now we got to actually make the request. So let's do def run cmd, and data, this can be the post request. So db, and then I think there's format string. I forget what the F stands for, but it makes us be able to do things much easier. So we want to put something that doesn't exist. So A, this is going to make it so we don't see the fortune. Then I'm going to do echo-n, please support me. And then we'll do cmd. There's going to be the command. And then echo-n on Patreon. We'll just leave it at that. And what that's doing is if we just put in something here, so we can do like echo-n test, echo-n test, and run this. Now a regular expression can just grab what is in between the two variables. So that's why I did those two. Okay, that should be good there. Now we got to make the request. So r is equal to, and this is all red, so we forgot something. There we go. Close out the single quote. Request.post HTTP 10.10.10 127/select. and then data is equal to data to send that post request, and we can print r.text. And this print can be run cmd. So now when we run this, we can do who am I, and we have the command, it being ran. You can see the please support me _fortune on Patreon. If we did lsla, you have that. So the next thing we have to do is the regular expression, just only grab the result of our command. So let's do, we can do page is equal to r.text, and then m is equal to regular expression dot search, please support me dot stir question mark, and then on Patreon, and that, and then the variable we want to search, we can say if m, so if this command found anything, whoops, then print m.group 1 else return 1. Or we can just print 1 here. This is really sloppy code. ls, and we're always returning 1. So if we think about this, we have multiple lines. So the regular expression's never completing. By default, the period doesn't match new lines. So if we just add another comma here and do re.all, that means the period is going to match everything. This will probably work now. ls, there we go. So now we have a pseudo shell. I'm just going to clean this up a little bit. We want to return, and we can do output and print output. So there we go. So have our commands, we can now see things on this box. I'm going to do a ps-ax, I think. There we go. And we can see what is running. So nothing looks interesting up there, except we do have NFS, but we didn't have any NFS ports. We have SMTPD. We have var appsrv fortune, SSH auth, and then the command we ran. And we also have Postgres. So let's take a look at what's in this var appsrv. So I'm just going to do find /var appsrv. And we have two things. Add a -ls so we can see the permissions. Let's see. Read. It looks like we can read almost everything. The only thing we can't read is this var appsrv SSH auth Postgres pass. At least that's what I'm guessing PG stands for. And we'd have to be the SSH auth user to read that. We can take a look at what this fortune.py is. So let's see. CMD DB selection. So this is the application that we are exploiting. So we see this is a Python Flask application, and whoops, I'll create a to-do here if you wanted to improve this. To-do decode HTML entities. I think that's what those are called. But in order to avoid cross-site scripting, it is putting the variables in HTML entities. So I think these are quotes. We could copy this over into Burp, go to decoder, and then decode as HTML. That is a single quote. So let's see, DBs, request form. So shell command is equal to cmd plus selection. Selection is that DB variable, and that just does os.popen, which is process open, on that shell command with no sanitization. So that is why our exploit's working. Let's go and look at the other application, which is SSH auth. So we can look at the configuration file first, see what this is. Doesn't really look too interesting. Let's do, where's the Python script? Go here, cat this file, and let's see what it's doing. Some type of SSH generation. So insert into authorized keys. We got SSH generation here. Connecting to the database authpf. User is appsrv. Doesn't have any passwords. So let's see. authpf is only there. So authpf is a BSD thing, I think. So if we do etc authpf, we have authpf rules. So if we cat this, we see the external interface is em0. If we do ifconfig, that is 10.10.10.127, and pass in quick on external interface TCP UDP from user IP to exdif. So this is saying if someone logs into this box, create these firewall rules. PF stands for packet filter, which is BSD's version of IP tables. So if a user gets in the box, then open up all the ports. So we have to figure out how to get on the box. And I'm guessing because of this being a Flask app, that this one is on port 443, that SSL that we couldn't access. So let's find out if we can, or see if we can find that intermediate CA for signing keys. So then we can create our own certificate. So I'm going to do find /-name. I'm going to do stir.csr, pipe errors to dev null, because we're going to read a bunch of directories and just get errors if we don't do this. Oh, it doesn't give error messages. Normally whenever I run these commands, I always send error message to dev null. So let's do name. Another extension for certificate is PEM, and we get a bunch of stuff in /home. So home Bob has a bunch of certificates. I'm guessing 1000.pem is probably going to be his user certificate. If we cat this, copy, we probably should create a way to save files in a Python script, but I'm lazy. So we can v 1000.pem, paste, and then do, what is it, OpenSSL. What's the certificate? It's not PKCS, the other one, X509. That's the type of certificate this probably is. -in, 1000.pem, -text. And we can see the subject is Bob at fortune.htb. The issuer is going to be the Fortune root CA. I'm not sure exactly what certificate this is. I really hate SSL. Let's just go back. And instead of figuring out what these certificates are, let's just download the ones we think we need and generate our own. So intermediate.cert.pem, this is most likely, just based upon where it is, going to be the intermediate CA's public cert. So we can get out of here. V, let's make our own directory, certs, cd certs, v intermediate.ca. And then we will cat this, whoops, and then go into copy mode, copy this all, and then paste it. So the next certificate we want is the private key, which is probably going to be in this private folder. So we can cat this, copy, and then paste this. So this will be intermediate.key. And .ca isn't a extension. This can be intermediate.cert. That's normally what public keys are called. Okay. So the next thing we need is, that's probably it. So we can try signing this. So we'll have to generate key. So we'll do OpenSSL gen RSA -out ipsec.key. We'll do 2048 bytes. There we go. Or 2048 bits. Now we have to create a certificate signing request. So OpenSSL request new key ipsec.key -out ipsec.csr. And we'll just put enter for a bunch of things. Actually, it doesn't matter, but for the organization name, I do want to put Fortune just for organizational purposes. And then FQDN, we'll do ipsec@fortune.htb. Again, these can be anything. This is just so when my FireFox pops up, I know which certificate to select. So we got my certificate signing request. Let's try signing this. So OpenSSL x509-request in ipsec.csr-ca intermediate.cert, then -ca key intermediate.key. Then we'll create a serial number for the certificate, and we'll export it as ipsec.pem days 1024 SHA-256. Looks like it generated. If we cat ipsec.pem, we can see that. We can also do OpenSSL x509-in ipsec.pem and see the subject of this certificate and the person who signed it. So in order to go into a browser, we have to package it up into PKCS12 format. So OpenSSL PKCS12 export out ipsec.pfx in key. This will be ipsec.key, my private key, -in ipsec.pem. This is the signed request. And the cert file is going to be intermediate.cert, the public key of the CA. Let's not put a password on it and hope everything works. So go into Firefox, certificates, go to your certificates, import, ipsec.pfx, no password, and we can see we are there. So let's do HTTPS 10.10.10.127 and turn burp off. And we want to make sure we give it our Fortune certificate. Click OK. And can't validate. That is odd. Let's try, maybe it's DNS. 10.10.14. Nope. 10.10.10.127. Fortune.htb. Try the host name. HTTPS fortune.htb. Give it the certificate. Why are we getting bad cert? Let's see. Certificates. It's always annoying. Authorities. This starts with an F. Fortune Intermediate. We trust it. Edit trust. Can identify websites. Sure. I don't think it needs that. That's probably just a really stupid thing to do. Let's clear history maybe. Clear everything. Fortune.htb. Don't remember. Go. Weird. I'm not sure why this isn't working. Let's see. Maybe it's time. Maybe the certificate or the server is rejecting our certificate. So let's go up. Run date 1944, and our server is 1952. So the box is a few minutes behind, which means it's probably rejecting our certificate because we're signing it at like 1950, and the server's like, wait, it hasn't hit that time yet. It's not valid. So we probably just got to give it some time for this to work. So if I'll just give it 5 minutes. So I'll resume the video at like 1957 and we'll see if it works. So it's been about 5 minutes. Let's just try it again. And success. So lesson learned, whenever you're doing anything with SSL or crypto and it's not working, make sure you check the time. I've burned a ton of hours with errors like that. So this page says you will need to use the local authpf service to obtain elevated network access. If you do not already have the appropriate SSH key pair, then generate one here. If we click this, it gives us the SSH key and it wants us to log in. So let's save this file. We'll save it as fortune.ssh, paste, chmod 600, fortune.ssh. I'm going to cat etsy passwd to see what user this most likely is. And we see at the very bottom, the NFS user has the shell user sbin authpf. So if we do ssh-i, NFS user at 10.10.10.127 and fortune.ssh. So -i specifies the key, and then we're going into this box. So it says, hello NFS user, you are now authenticated from the host 10.10.14.3. So we can do nmap -p- to do all ports, 10.10.14.3, and we'll do -v so it shows us open ports as it finds them. 10.10.127. Don't want to nmap ourselves. And if you want, you can always just go to like Google and do authpf openbsd, and you can see exactly what it is. User shell for authentication gateways. So let's not do -p-. Let's just do that to get the top 1000 ports and see what else it responds on. We have port 111, port 8081, port 2049. We can see what 8081 is. So if we do :8081, secure connection failed. We can do like OpenSSL S client connect 10.10.10.127 8081, and probably not HTTPS. pgadmin4 service is unavailable. See Charlie for details. And then we also get 2049, which makes sense because that's the NFS port, and we are the NFS user. So we can do showmount -e 10.10.10.127. Not found. apt install. I think NFS-COMMON is what this is. And if you want a good video on NFS, go back and watch my jail video. It's one of my earlier HTTP videos. but that box had a ton of things to do with NFS, so definitely check that out, as we're only going to scratch the surface here. So now that the NFS-COMMON package is installed, we can do the showmount command, 10.10.10.127, and we can see the share/home is accessible by everyone. If this had an IP address here, then it would only be accessible to that IP. This is also, I think, works with host names as well, but everyone means we should be able to mount it. So I'm going to do mount-t NFS -o VERS, stands for version 2, then 10.10.10.127, specify the home share, and then we're going to mount it in /mnt. I specify version 2 because NFS version 2 doesn't really have any authentication or authorization. It trusts the client to provide everything. So if we go into /mount and do a LSLA, we can see the users of home. If we try to do ls Charlie, we give permission denied. But we can see that's UID 1000. So if I just create the user, please sub, and we edit my UID to be 1000, we'll be able to access that Charlie user. So change please sub to 1000. I'm also going to go change the user IP to be 1001. So now if I do LSLA, we can see IP is the owner of Bob and please sub is the owner of Charlie. So if I do please sub, and then we go cd/mount Charlie, do a ls, now we can get in. We can do wc-c user.txt. See, we can read that file. There's also the file mbox, which is from Bob to Charlie, and he's telling him that he has set the DBA password for Postgres to be the same as the root password. So now we have to know there's a password inside the Postgres database, and that password is going to be the one that we can use to sudo root. So let's first try to escalate to the Bob user. So let's see, ls-la. We have the .ssh directory, so we can create the authorized key. But before I do that, I'm just going to test something with SetUID binaries, because that's generally how I exploit NFS servers. So let's just see if that path is valid. So I'm going to su to the IP user because that has the same UID as Bob. And Bob has the directory that is world readable. So we could just create stuff in Bob and execute it from the web server. So if we can put a SetUID program here, then potentially we could just run commands from the web server as Charlie. So I'm going to touch test, and then we're going to go into Bob from Charlie, and we can do chown. Who is my user here? Please sub test, and NFS isn't letting us change the owner of the file, so can't really do anything there. Because SetUID will take the permissions of who owns the file, and if we can't change our owner, then we're dead in the waters. We can try chmod 777 test, and now try this command again, chown, please sub test, and we still can't. So let's just go down the path of SSH. So cd Charlie, and again, if you want to see that SetUID binary stuff with NFS, check out the jail video. So go into the SSH directory, and then we just have to generate a key. So ssh-keygen -f charlie.ssh, and we got Charlie SSH pub. So we can copy this, echo, whoops, echo. I hate when I copy line breaks. I just did it again. There we go. 2. Whoa. Terminal screwed up. Hopefully this works. Authorized keys. And I typed that all. Let's just Control C, maximize the window, and do this again. Echo, paste, to authorized keys. Cat, the file. Okay, we have written that. So we can do chmod 600 charlie.ssh, ssh-i, charlie.ssh, charlie at 10.10.10, 127, and we are in the box as Charlie. And now we should be able to go into the appsrv directory we saw as the web user. So pgadmin4, lsla, and we're in. So if we do file pgadmin4.db, we see it's just a SQLite 3 database. So do SQLite 3 pgadmin4.db, and we could do .dump to dump the database, which we see looks like the credentials right here. But if we want to be a bit more surgical, we could try .schema, and this is going to be like show tables or describe database or things like that. But we can see all the columns in each table. So if we just ran the command .schema and grep for create, let's do grep-i for create, we can see all the tables. So we got user, or version, user, role, settings, whatnot. But passwords will probably be in user and server. So we could just do select star from user. And we see two things. So let's copy this. And let's see. I don't think we need that authentication anymore. Exit this. The notes. Paste that. That'll be helpful. And then we do need that. Let's do that SSH command again. Why'd I need that? I thought SSH was listening. Yeah. So I guess just closing that NFS thing when packet filter reset, it killed my SSH connection. But yeah. Let's go back into var appsrv, pgadmin4, do my history. I don't. We can do SQLite 3, pgadmin4.db, select star from server, and then grab this as well. So now we have to find out what exactly this is, because it looks like base64, but if we echo-n, paste base64-d, we don't have base64 command. Let's go down, echo-n, base64-d. It's just gibberish. So it's encrypted somehow, so we have to figure out how to decrypt this. So if we cat pgadmin4.ini, the configuration file, it's pointing us to a few things. We got a virtual environment, web, socket. Let's check this. Virtual environment looks like it's just like libraries for this Python package. Web, if we look in web, it looks like this is the source code to the application. So what I'm going to do is we'll do a grep-i for case insensitive, capital R to go recursively, -L to only show me file names, and let's try password on everything. And we get a ton of hits on password. So let's do something different. Let's see, how do we do decryption? So we do that on decrypt, and we have much less hits. So let's see, pgadmin utils crypto.py, that definitely looks interesting. So if we go into this, look at decrypt, we can see it's a function. You pass the ciphertext and the key. So now we want to find what the key is. So I'm going to do grep-r, again, recursive. And we're going to look for everything that calls decrypt. And we see up here, the server groups init.py. Decrypted password is equal to manager password and user password. And again, all of these are calling user password. If we look into this, we could potentially see it. Let's look at user from Flask Security, import current user, login required. Let's see, decrypt, decrypted password. Let's see. I'm not sure exactly where this is getting set. grep-r. It's probably in one of those Flask libraries, which means it's going to be pane. Let's do IRL. Let's see. I'll leave that for you to hunt around for where that password is being set. Let's just copy this config file. So if we go into crypto.py, let's just copy this into /temp chmod 777/temp crypto.py, and then we will execute it with a web server to cat it, so Python 3. Now to view it, just an easy way to get it on a box. I guess I don't know why I'm even doing this, because we could just do it this way. The same exact thing. Cat. We'll just cat the file. For some reason, I was thinking my Python script had the ability to download files, but it doesn't. So we'll just do it this way. Copy it. Go here, v crypto.py, paste, set mode to paste, paste. And now we need to decrypt, and we just need to paste it in. So I guess I can save notes, cat notes, and we want to take this, paste, and I think the message was from Bob to Charlie, so we can do his password, which is right here. Copy this, which is the user password. That didn't paste what I wanted to. Paste it. And when we execute, we have to do print. I don't think this is a Python 3 library. There we go. So reuse of passwords like this is a bad idea. If we copy this, try it in the Fortune user, we can escalate to root. So that is the box. I hope you guys enjoyed the video. Sorry it's short and probably not as in-depth as normal, but talking is painful right now as I'm just getting over a cold. So see you all next week. Take care.